1.5 is using problem-solving strategies and models. Okay, a verbal model is basically a word equation. Okay, verbal model, when they ask you for a verbal model, they want it written in words or the equation written out in words, so it's a word equation. So instead of having something like 3x plus 6 equals $120, you would say 3 hours of working this shift plus $6 in tips equals $320. You would write it out in words. Okay? So we're going to go over 3 word problems from this section. All 3 are in your book, but we're going to discuss and go through them. What? Didn't have homework? No. And then for your homework tonight, I'm actually going to give you a practice sheet that has 4 different word problems and walks you through steps of how I want you to help me set it up, okay? So we can practice doing it, and then tomorrow we'll come back and do more word problems out of the book, okay? So that's what that's going to look like. That way we can get used to word problems, breaking them down more, and all that fun jazz. First word problems here in pink. I guess this is, how would you pronounce this? I don't know. Anyhow, this train travels between Boston and Washington, a distance of 457 miles. The trip takes 6.5 hours. What is the average speed? Okay, so how could I set that up into an equation? How can I set that up into an equation? What information do I have? That's a better question. Do I know how far I'm traveling? 457 miles, and that is my distance. Do I know a formula for distance? What is it?
Is it D?
Distance equals time times the, or the rate, okay? Rate times time, okay? So distance equals rate times time. So you told me the distance is 457 miles, so I can plug that in for D, okay? 457 miles equals, the trip takes 6.5 hours. What is the average speed? So what other information do I have? Do I have the rate or do I have the time? The time, and I know the time is 6.5. This tells me that it's time. Okay, I want to know what the average speed is. So I'm going to set up my equation to say R times 6.5. And it's 6.5 hours, right? Times R. So that's what I'm trying to figure out. So I'm going to take, how would I solve this? I'm going to take what? Okay, yeah. I'm going to divide everything by 6.5 hours. So that over here, this will cancel, right? And then over here, I'm going to have some type of number, miles over hours, miles per hour, okay? Which would make sense because I'm looking for a rate or a speed. Is miles per hour a type of speed for us? Yes, okay. So what is 457 divided by 6.5? $70.3. So 70.3 miles per hour. Okay? 70.3 miles per hour.
Which is that R?
So that, yes, so that is my rate. And now I've solved what is the average speed. The average speed is 70.3 miles per hour.
So we need to just make that in words now?
Nope.
Oh, okay.
That's all we wanted to do on this one. We wanted to take this, convert it into an equation, plug in the words for our equation, which we did. It has words and numbers together, right? 457 miles is my distance, 6.5 hours is my time, and my answer is technically in words and solution, 70.3 miles per hour. Okay, does that make sense? Okay. So So that's what we're looking at there. Then you come over to this next one, okay? A paramotor is a parachute propelled by a fan-like something. I don't know. I guess I didn't copy that. A fan-like motor. There we go. Is a parachute projected by or propelled by a fan-like motor. Sorry, I missed that word. The table shows the height of a paramotorist T minutes after beginning a descent. Find the height of the paramotorist after 7 minutes. Okay, so T equals minutes, height equals feet. This is the table to give me 0, 1, 2, 3, 4. At 0, it's at 2,000, 1's at 1,750, 2's at 1,500, 3's at 1,250, and 4 is at 1,000. Okay, it wants to know how high the paramotorist is after 7 minutes of falling. Okay, so what do you think we need to figure out first? If they give us this chart, we probably need to look at the chart and do what? Okay, what the height difference is. Good, Cole. What the height difference is. So what is the height difference between 2,000 and 1,750? 250. What is the height difference between 1,750 and 1,500? 250. Okay, does it continue the same for the other two? Yes. Okay, so the difference is 250, which is good. All the differences are the same. Okay, and it's down 250, right? Which makes sense because I'm falling. A parachutist is falling. Okay. So it's down 250 is the difference between all those. Good job. Okay. Now it wants me to solve find the height of the paramotorist after 7 minutes. So I know my equation should say height equals something, right? Okay, because I'm trying to find the height. They told me that. What is the starting height? 2,000. So my height's going to equal 2,000, and then what? How can I figure out what my new height is? 2,000. Well, it wouldn't be plus because I am falling, right? So subtraction. So 2,000 minus what? What do you think? If I start up here at 2,000 meters, or 2,000 feet, and I want to know where I'll be after 7 minutes, what this height is, okay? How can I figure that out? This is at 0 minutes. This is at 1 minute. Okay? I gotta go all the way down to 7. So what do you think I am subtracting from 2,000? Okay, 250. Not just 250 though, because if I only subtract 250 from 2,000, I get after 1. Good, 250 times my time, times 7 minutes. Okay? Awesome, good job. 250 times my time. So my actual equation, if I had it in symbols, would look like this before you do anything else. Okay? So this is what it looks like in symbols. Then I plug in 7 minutes for t. 7 times 250 is what? 1750. And what does 2,000 minus 1750 come out to be? 250 feet. And your answer has to have feet with it. So after 7 minutes of falling, you're only 250 feet above the ground. Pretty quick fall. Okay? So this is what we have to be able to do. We have to be able to take simple 1-2 step things, set up an equation with symbols, plug things in. We have to be able to take more complicated series with tables and charts. You guys did a good job of finding the difference between everything first. We knew that h equaled whatever my original height was, and then we finally got to this point of the negative 250 times my time. From there it was easy, okay? So this is the type of stuff we're looking at tonight. The last one that we're gonna look over is another word problem. This one's a little bit longer. And if I were you, after reading this, I would draw a picture because that's how I have to think it through, or else I can't visualize it. So let's read through it and we'll see what we know, what we can pull from it. You are hanging 4 championship banners on a wall in your school's gym. I always read one sentence at a time when I'm doing this and highlight the things that I think are important, such as I'm hanging 4. Okay, that's a number. I probably need to know that 4 banners are going up. Okay. Then I go to the second one. The banners are 8 feet wide. So 8 feet. I probably need to know how wide they are. The wall is 62 feet long. So the wall, 62 feet. Okay. There should be an equal amount of space between the ends of the wall and the banners, and between each pair of banners. So that doesn't have any specific number in it, but I know that it needs to be equal. Okay, so I'm going to underline that. How far apart should the banners be? So I want to know, how far should they be placed apart? I'm looking for the distance between things. Okay, so how many banners did we have? We had 4. So I'm just drawing 4 boxes so that I can represent those 4 banners. Does that make sense? Okay. So I have 4 banners. It says the banners are how many feet wide? 8. So I'm going to label this as 8 feet, the width of that, okay? Oops. All of these are 8 feet. The wall is 62 feet long, which is also a width, right? 62 feet, okay? So I know that the wall is something like this. Come up right here. Okay, let's just represent this with 62 feet. So now I have a visual of what this should look like a little bit. Okay. There should be an equal amount of space between the ends of the wall and the banners. Okay, so an equal amount of space. So if I name this space X, this should be X, 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 and X. Does that make sense? Okay, I need equal space between each thing, so I just labeled it with X. Okay. How far apart should the banners be placed? That's my final question. Okay. So, what makes up this 62 feet? 62 feet equals what? What does that 62 feet equal? Not X times 8. This width right here is X, okay, from here to this corner. This width right here is 8. So I'm not multiplying, I'm doing what? This width right here is X, what? Not dividing. I'm adding this, I'm adding this, I'm adding this, I'm adding this, I'm adding. Okay? Because all those added together are the whole, all those little parts. How many, so really what it would look like is X plus 8 plus X plus 8 plus X plus 8 plus X plus 8 plus X. Okay? How can I make that, how can I simplify that? There are 4 X's? 5X? Okay. So I have 62 equals 5X plus what? 8 and 8 is 16, right? 32. Now what do I do from there to solve? Subtract 32. What's 62 minus 32? 30 equals 5x. Then what do you do? Divide by 5, and x would equal 6 what? 6 feet. So in order to space those evenly on that 62-foot wall, there needs to be 6 feet of space between the wall and a poster and a poster, poster, wall. Okay.
Seem like-
That
probably
one-
seems more complicated.
It does seem more complicated, doesn't it? It does seem more complicated, that is true. Okay. It does seem more complicated that way. So those are the types of things you're doing.